Hi, folks. I hope you enjoyed the warbling of those magpies. That was lovely sound to come into. Welcome, everyone. I'm Remy. I'm in the Climate Emergency and Environment team at the City of Glen Eira. Thank you for coming along to the webinar tonight on sustainable building materials. This webinar is hosted by the City of Stonington and the City of Glen Eira. I'd like to start by acknowledging the traditional owners of the land on which we're meeting today. Of course, that depends on where you're calling in from, but across Glen Eira and Stonington, we're on the lands of people from the Eastern Kulin Nation, the Wurundjeri Woiwurrung people, and the Bunurong Bunwurrung peoples. I pay my respects to their elders, past and present, and I extend that respect to any First Nation peoples joining us here tonight. And I acknowledge the thousands of years of First Peoples custodianship of this land and all its living things. Also a shout out to Rebecca Kootstra, who's here from the City of Stonington and was your host in previous webinars in this series. So this webinar is part of Stonington's Towards Zero series with webinars on various topics, which is running until June. And it's also delivered as part of City of Glen Eira's sustainability program. So both programs are supporting each council's climate action plans. So without further ado, I'd like to introduce Dr. Martin Frenny. Dr. Frenny is a designer, educator, and researcher in the field of sustainable design and architecture. He's very busy, so we're very glad he could make it tonight. He's an academic at the University of South Australia and runs his own consultancy, Earthship Eco Homes. Earthship Eco Homes develops housing solutions that minimize environmental impacts and maximize resilience to climate change. He's eminently qualified with a PhD in this very topic, as well as qualifications in industrial design, building design, construction, and permaculture design. And he brings all of this knowledge to creating solutions to ecological housing. So, yeah, take it away, Martin.
Thank you very much, Remy. It's my pleasure to be here. So tonight I want to just give you a brief introduction to this topic of sustainable construction materials, look at design considerations and material properties, introduce you to an important key concept, which is embodied energy and embodied carbon, and that's closely associated with life cycle thinking and life cycle assessment. And another really important thing that you can do to be more sustainable when you're buying materials is look for certification labels. So I'll be talking about that too. And then I'm just going to go through systematically, floor, walls, roofs, insulation materials, windows and glazing, looking at the typical materials and also some unusual eco materials that go into those main construction elements. And I'll finish with a case study of an eco home and give you some eco renovating tips. So to start with, I think it's good just to acknowledge this idea that in the past, people built with what was available. And these days, we've sort of got a globalized economy where we can get materials from all over the world. But building with local materials, the materials at hand, is indeed a very ecological way to build. And I know what you see on the screen doesn't seem very practical, but you can indeed, even these days, build with local materials. So I'll give you some examples of that as we go through. So this presentation is about materials, and I'm not going to talk too much about design because there's other webinars on that topic. But I will touch on it from time to time because it's almost impossible to talk about design without, talk about materials without talking about design. So I've got some questions here. What will we build and how will we build it? And so we can't talk about design without talking about the designers, which are you and me. We all have ideas about how we want our homes to be and what types of materials. And of course, these decisions that we make have a massive impact on things like the cost of the home. And in particular, a really important one is how much is it going to cost to run? Of course, how much is it going to cost to build? But also increasingly, people are thinking about, what are the ecological impacts? And of course, that's what I'm going to be talking about a lot tonight. And so right at the beginning of the project, as the floor plan is being developed, this is when the materials and costs are locked in. So this is really the greatest time to have a major impact on the outcomes of your project, keeping in mind those things I just mentioned about how much is it going to cost to heat and cool your home, and of course, how much is it going to cost to build, and things like are you going to enjoy living in this home? Has it been designed to comply with all your requirements? They might be in terms of accessibility or getting the views you want to see. All these things, of course, are locked in at this stage. And one of the main things I really would love people to consider is the size of their home. And I'm not saying here that we should all be living in tiny houses, although maybe I should be saying that. Uh, we Australians actually build the biggest homes in the world, and I think that does need to be called out. You can see from this graph that there are people living in other parts of the world. Let's pick the United Kingdom, for example, living in 76 square meters. That's approximately a third of the size of our homes. So please keep that in mind. And important to understand, I suppose it's very obvious that big houses need more energy to heat and cool, and of course they need more materials to build and cost more to build. So if you are on a budget, it does seem to make sense to consider this size issue. All right, so design and approval. Of course, there's a team of people who are working together to get you approval for your build, and this is where materials are going to be locked in. So all of these people here are going to have some impact on the materials you choose, whether it's say the energy assessor is going to have some specifications for your glazing. Hopefully it's double glazing. The structural engineer will be specifying the strength of the timber or the steel. So it is kind of a team approach, and these materials sometimes it's a little bit out of your control as the owner of the building, and you'll need to take the advice of these experts on what are the right materials for your home. But right from the beginning, you can start out by saying, well, these are my preferences for the types of materials I want you to work with. An example of that might be, do you want a timber framed home or a steel framed home? So material properties. Lots of things to consider. And I'm going to sort of scratch the surface of these things tonight. So I've mentioned this idea of embodied energy, which is the energy used to make materials themselves, the energy required for manufacturing. And then there's the operational energy, which is your heating and cooling energy. And then there's this all leads into the environmental impact or your ecological footprint, how sustainable the build is. Another important thing which also ties in with sustainability is the durability and longevity, resilience to things like weather, bushfires, termites, condensation, and mold. All these things are determined by the materials you choose. Aesthetics and beauty, that's subjective, of course. So you will have your own ideas about what you think is beautiful. The cost is a massive consideration for most people. Maintenance, which I guess is related to cost, and also availability. And throughout COVID and even after COVID, we've sort of experienced some hiccups with supply of materials. And I should also mention the cost of materials has gone up post-COVID. Now, perhaps one of the most important material properties is this concept of insulation and thermal mass, and they're really at opposite ends of the spectrum. And insulation and thermal mass are really the ingredients that are going to determine whether your home is energy efficient and therefore nice to live in without relying too heavily on things like air conditioners. And different climates and different designs are going to call for different amounts of insulation and thermal mass, and indeed the construction codes and standards are going to specify minimum amounts of insulation in particular. So let's have a quick look at these two things. So insulation, I'm sure most of you are familiar with this concept that it slows down the flow of heat. It's good to understand that heat flows from hot places to cold places. So you know, if it's warm inside and cold outside, the heat's trying to escape. It's measured with something called R value and also U value, and I'll explain these two things as we go along. And obviously, the conventional insulation material that you can get at any hardware store at the top there. And thankfully this fiberglass insulation wool is made from a lot of recycled glass these days, so that's terrific. But down the bottom, I've shown a straw bale home and a straw bale, which is really terrific insulation, partly because the walls are so thick. So we'll explore that a little bit more as we go along. So yeah, we've got the fiberglass wool, also a similar product that goes in the roof, often with a reflective foil called a roof blanket. There's also rigid insulation, such as polystyrene foam, which might also have a reflective layer on it, and that may go under your floor. Straw bales or hempcrete blocks are sort of alternative building materials with very low eco footprint. And then spray foam insulation is another possible way to insulate walls, floors, and ceilings. So let's look a little bit at this R value measure. So yeah, as I mentioned before, R value, you can see on the table over here, I've highlighted the 50 millimeter thick values for R value. So if you look down the list, 2.78 is the highest for phenolic insulation. Rock wool is around 1.5. Glass wool insulation is also around 1.5. And another thing to understand is that if you halve, so going to 25, if you halve the thickness, you halve the R value. So it's just directly proportional to the thickness. So what this means is that thicker insulation is better. Twice the insulation will give you twice the R value. And another thing to understand is that the U value is just the opposite of the R value. So if you do 1 divided by R, that gives you the U value. So what we're looking for is small numbers for the U value and large numbers for the R value is giving you the better result. And the U value tends to get used more for glazing. So when we get to the windows, I'll remind you about this U value thing. One other thing to understand is that in America, so if you're Googling and finding information about R values online, if they are coming from somewhere like America where they use imperial units, it's going to be approximately 6 times better sounding. So don't get fooled by that. Insulation is the kind of thing that can get skipped over. So in your project, make sure that you, I would say, supervise the builders. Make sure they're doing a really good job at making sure there are no gaps and that that insulation is not crushed, because if it gets crushed, it will lose its R value, because it's not as thick as it was meant to be. And a really wonderful resource for everyone is the yourhome.gov.au website. It's a government website which is all about how to, design a great home. And there is, of course, a lot of information there about insulation. So yeah, more great resources there for you. So thermal mass is the other one that I feel is a little bit less understood and not utilized as much in Australia as it could be. So the idea of thermal mass is that you can store energy and release it later on. So it does act a little bit like a battery. So thermal mass is things like concrete, for example, in a floor, fired clay bricks, mud bricks, rammed earth, and even water is thermal mass. So I've even heard of buildings that have rainwater tanks built into them, typically a concrete rainwater tank, which is also thermal mass. And the idea is that thermal mass can store the temperature that is collected from the sun, for example, or it might be collected and stored in the water, in the example of the water tank house. So in this photo here, this is in my earthship, and I'll talk more about earthships later, but here you can see the sun hitting the earth floor, and what that means is at nighttime that floor will release the heat into the air and warm up the air overnight. And of course, in the summer, with proper shading, that keeps the sun off the floor so it doesn't warm up in the summer. And so again, there's more information about thermal mass on the Your Home website. And so really what designers try to do is combine these two materials in an intelligent, logical way. Sort of, I gave you a few clues previously about, letting in the sun in the winter, but not letting it in the summer. That's all super important. But yeah, how you arrange these materials so that you get a good outcome is the trick. So in this example here, this is what's called a reverse brick veneer wall, and the idea here is that the bricks on the right hand side, the bricks are on the inside of the building, rather than usually what we do is we put the bricks on the outside. So by putting the thermal mass inside with insulation on the outside, that really improves the indoor temperatures and reduces your heating and cooling needs. So I love this idea. It's very simple because builders know how to work with these materials, and they're just really just swapping the two layers around. A few more images here from Your Home website, and here I wanted to make the point that if you've just got a brick veneer wall that's uninsulated, only gives you R0.45, and this is not enough to satisfy code. So this is where, yeah, some other layers of insulation, good idea. It's the same with cavity brick, and solid walls are also typically not going to meet code. Well, not typically, they just won't meet code. So some other type of insulation is very important. And then there's the reverse brick veneer again, which I think is a really great way that a conventional builder can get a great outcome. So I think, yeah, if you've got a renovation project planned, talk to your builder about reverse brick veneer. So In summary, insulated thermal mass is a good design strategy in many climates. Ask your designer about the strategy to minimize heating and cooling requirements. Okay, eco impacts. How to reduce the eco footprint of construction materials. So we've got really quite good at reducing the operational energy or the heating and cooling energy to run a building by using some of these techniques I've just been talking about. The next big challenge is how do we reduce the embodied energy of the construction materials? And as I explained before, that's the energy required to manufacture those materials. And what's more, we also need to think about the end of the building's life, because we don't want to create this problem 50 or 100 years down the track where we're trying to figure out what to do with these buildings that might end up in the landfill if we're not careful. A better idea is to do what's called the circular economy, which is where we upcycle materials in an ongoing loop and bypass the landfill and simply make new buildings out of the old buildings. So an important concept to understand is this life cycle stages idea, where you're thinking about raw material manufacture, construction on site, the operation of the building throughout its life. So that's typically the heating and cooling energy, but also things like maintenance. And then its end of life when it gets disposed of. And then throughout all these stages, we also need to be thinking about transport. And that goes back to the very first slide of the indigenous housing, where I mentioned this idea of how do we use local materials instead of trucking or flying materials right across the planet. So life cycle thinking. So here's a diagram which sort of illustrates that during raw material manufacture, we've got embodied energy, same during production. The use phase is the operational energy. There's also embodied energy when we demolish the building. And if we can take that those materials and turn them into raw materials again, then we've got the circular economy. And then note that the transport energy is, it's everywhere. So number one, raw materials in production. We can probably have the most impact here by eliminating wasteful construction practices. So the illustration here of the skip bin filling up is an example of perhaps a slightly dysfunctional manufacturing system. So maybe prefabricating components and having them delivered to site could avoid some of this. So consider prefabrication. The use phase or occupancy, we all want to decrease our energy bills and water bills, etc. So of course, this is where design and correct material selection comes in. End of life. I'm sure we don't want to see this kind of rubbish occur at the end of the life of the building. So to sort of help get you thinking about this whole issue of life cycle of materials, I just want to do a quick look at timber. So first of all, of course, we have to grow a tree. And this is actually going to get more difficult with climate change, things like droughts, erratic weather, and not to mention the fact that we're clearing forests at an alarming rate, not only in Australia, but on a global scale. Then we have to turn that tree into a material. And of course, there are problems with that as well. Social issues as well as sustainability issues, massive amounts of transport, pollution. There's also, of course, the energy required to mill the timber, kiln dry the timber. Perhaps a more ecological thing would be to air dry the timber. Maybe even more ecological would be a solar kiln, but perhaps not very commonly available. Then there's ongoing energy required to safely store the materials, transport the materials to your site. And the point of this picture is that it says here this vehicle is 100% electric, zero emissions. So, there are good initiatives like that to start addressing the eco footprint of transport. Then we've got waste during the construction stage. Finishes and maintenance. Every type of material you're going to need to think about, how's it going to be preserved so it has a longer lifespan and doesn't need to be torn up and replaced. And then, of course, demolition. Is it going to end up in landfill? Is it going to be incinerated? Or perhaps through good design, could it be designed for disassembly, like this example here? So in summary, there's lots of opportunities for us to influence the ecological, economical, and social outcomes just by thinking through these life cycle stages. So some examples here is like, can we get FSC certified products instead of getting old growth timber? Can we avoid the waste on site? Can we ask the builder that, we'll let them know that, this is really important to us and we don't want to be paying for skip bin after skip bin to be emptied, or prefabrication may be the solution there. During the use stage, can we specify eco-finishing and maintenance products, which perhaps use natural ingredients rather than petrochemical toxic ingredients? And at end of life, can we design for disassembly? So, embodied energy. I just wanted to show, just real quickly, I don't want to spend too much time on this topic, but this is again from yourhome.gov.au. It does go into this embodied energy issue, and what you'll discover, I mean, the big baddie on this list is aluminium at 358 megajoules per kilogram. So just sort of having a little bit of an idea of, really, you can think of this as the pollution factor and the eco-destruction factor. This is sort of a good thing to have in the back of your head. It's not something that gets talked a lot about in the building industry, but I think over the years to come, you'll see that this becomes more and more a part of even how you get approval, because you'll need to demonstrate that you've considered this issue of embodied energy. And embodied energy ties in closely with this idea of life cycle assessment, but it goes beyond embodied energy and it starts thinking about what are the impacts to water, land, and air, and even like toxicity to humans. And so there are, this Circlos is some software that will basically tell you what the ecological impacts of your project is. And as I mentioned before, I think this will probably become mandatory in future, but not yet. So this is really only for diehards who really want to understand what the eco impact of that building is. Where it does get used right now is in certifying products. You'll see right at the heart of this flow diagram, it says LCA, life cycle assessment. And so by doing a life cycle assessment, you really can judge how ecological a product is. So this is how you can actually get your product certified in this case. But more importantly, I guess, to people like you who are watching tonight, what I did is I typed in insulation in the global green tag product finder, and it brought up a range of 40 products. It says here, only 6 are on display now, that shows you, what are some certified insulation products. Because I guess the unfortunate thing is there's a lot of greenwash out there. There's a lot of people just outright lying or not being completely honest about how green their products are. And so, if they've gone through this process, then you can be reasonably sure that you're getting what you think you're getting, which is an eco product. So here are a few certification schemes related to construction materials. The Forest Stewardship Council I mentioned earlier, in relation to timber products, and the Green Tag Certified and Good Environmental Choice Australia, a couple of other ones. All right, so moving on now to waste and recycling, creating the circular economy. It's also good to just have this sort of overview of these key ingredients. Concrete, timber, and steel, all very common in most constructions. What you'll notice is that concrete tends to get downcycled or into thankfully, only about 5% hits the landfill. 75% gets downcycled gets crushed up and goes into things like roads. Timber, a lot ends up in landfill, which is not great because it breaks down and creates methane and causes global warming. And the real champion here is steel, because hardly any of that goes in the landfill, and 93% of it is getting recycled. So that's terrific. Doesn't mean steel is the best, but it is certainly an advantage of steel. And so, again, from yourhome.gov, there's some information about how to avoid waste. And really, it all comes down to good design. Of course, if you build a smaller home, that's going to reduce waste at the construction phase and end of life stage. And you really do have to work with both your designer and builder to do this waste minimization thing. So another thing that you can do is salvage materials. It's not necessarily easy or cheap. The problem I've personally had is just once I've found a pile of materials I want to incorporate into my project, you have to store them safely and keep them protected from the weather. And I guess the other thing is issues with compliance. So the example I've given here in the third dot point is if you're trying to salvage windows and you're in a bushfire risk area, they might not be made out of the right timber. So I think that kind of the easy thing to do is get some secondhand fixtures and fittings, and that should be relatively easy rather than looking at things like windows and doors and structural elements. All right, moving on to toxicity and safety. And basically here I've thought about those stages. So the construction stage, we don't want builders getting sick. We don't want you getting sick while you're living in your home. And when it comes time to demolish the home, we don't want that causing toxicity and safety issues either. So we're all familiar with this asbestos. Aluminium cladding has been one of the latest disasters, and engineered stone is the most recent alarm has been given about this one, and they're actually phasing this product out, as I understand it. So good to be aware of that one. Perhaps avoid specifying that for your new countertops. And also I think I mean, I've given this example of the spray foam. You can see the workers all suited up in a hazmat suit and a respirator. So, wearing the correct PPE can solve some problems, but imagine if this building was on fire and all the toxic fumes that would be emitted from the polyurethane foam. So, um, yeah, and you just got to hope that that's not causing nasty off gassing while you're living in your home. So, yeah, this is why I guess, yeah, I'm a big fan of natural materials, and earth is my favorite non-toxic material. Um, Obviously, it's highly abundant, cheap. It's probably got the lowest embodied energy of any material there is. Uh, it can be very durable, um, depending on how you form it. So, you know, rammed earth walls, for example, have lasted for hundreds, if not thousands of years. And there's a really great organization called the Earth Building Association of Australia. There's their website. They run conferences and workshops, and have some good information on that website about how you can build with earth. So, all right, let's have a look at some construction elements now, starting with floors. Basically, in Australia, you more often than not you end up with a concrete slab, but maybe it's a timber floor, or maybe it could be something else. So, in this diagram here, you can see a concrete slab. This one actually has underfloor insulation. It also has insulation on the side of the slab, which stops heat loss from the building, or not stops it, it slows it down. And so there's also a plastic barrier underneath. So I guess another thing to start to understand is that these materials come as systems. A concrete slab is not just a concrete slab. And of course, inside the concrete slab, there's steel reinforcing. So, yeah, once you sort of decide upon an idea that you want a concrete slab, that kind of leads to a whole suite of materials that are almost a little bit non-negotiable. So there's a concrete slab under construction, and yeah, there's a lot to be said for a concrete slab. They're one thing I really like about them is that they add thermal mass to the building, and that's in most climates going to be a real asset for helping stabilize internal temperatures. And these days, you can also request eco concrete, which and here I'm linking you to a article by Renew, which explains this concept of eco concrete, and some of the larger suppliers are now providing this. And basically, it uses waste products from coal-fired power stations and steel furnaces. There's products from them, waste products that act like cement, and so you substitute the cement with these other products, and that reduces the eco impacts. So another great thing about concrete slabs is you can put water pipes in them to create what's called a hydronic heating system. And you can put electrical heating elements. I think as far as I know, the hydronic floor heating systems are more efficient, more energy efficient. And you can, of course, put different finishes on the slabs. I prefer the example down the bottom of the polished concrete, because that leaves the thermal mass exposed and ready to soak up any sunlight that may be hitting it. By covering over with timber, you tend to negate some of those thermal mass properties of the slab. And then, yeah, the other common construction method, of course, is the timber framed floor. Yeah, hopefully it's obvious that that is not thermal mass, and this may be more appropriate in the tropics, and of course in the tropics where flooding is more likely to occur. That all makes sense to get the building up off the ground on some stumps or posts. And yeah, that lighter weight construction can be better in the tropics where it's important that the building can cool off at night time quickly. So too much thermal mass in the tropics can be a bad thing. And of course, get your termite solution right if you're building with these materials. Um, keep in mind that, yeah, a lot of these timber products can be termite treated, but of course that involves a lot of toxic chemicals. Uh, timber is, of course, very beautiful and renewable. We can grow timber. We can't grow more steel. There is a finite amount of iron ore in the ground. So, yeah, I love renewable materials because we can just grow more and more of them. And the challenge then, of course, is we need to plant more trees than we cut down. And that's where the Forest Stewardship Council can help with certification of timber that does come from those sustainable sources. But perhaps my favorite type of floor is the earth floor. And I've already shown you a photo of my earthship with the earth floor. Here is a great book that tells you how to do it. A problem you'll have if you do an earth floor is you won't be able to find anyone who can build it, although I guess I could connect you with at least one person I know who is a professional. And you may have problems getting it approved, but usually there's a way to do it. And they are very, very ecological and very beautiful. And it's how we used to do it back in the good old days. So yeah, once again, there's my earth floor and my earthship. And this is a photo of it under construction, applying linseed oil, which waterproofs the floor and stops it from feeling dusty. All right, so moving on to walls, looking at framing materials, insulation materials, cladding materials, and lining materials. So, yeah, look, the two main options are steel framing and timber framing. And these days, yeah, the steel frames tend to get prefabricated and it gets built fairly quickly on site. One of the downsides to steel framing is that if a window is changed size or something like that, it can be a bit tricky to make modifications on site, whereas a timber frame is that bit easier. So another huge advantage is the termite issue. If you are, as I said before, building with timber, make sure you've got your termite control strategy figured out. It is a easier material to work with. It can also be prefabricated and get erected on site very quickly. So there is no clear winner with timber framing versus steel framing. So I think best to talk to your builder and see what they prefer to work with. Perhaps one thing I do like about timber is that it's insulative, so you don't have problems with thermal breaks, which is where with a steel frame you get heat conduction out through the roof in particular. But of course, there are ways to mitigate that. So as long as you're aware of that issue, you can control that problem. So here's the reverse brick veneer again, which I guess the tip here is to use 140 millimeter studs. Usually they're only 90 millimeter, but that 140 millimeters gives you more room to put insulation in the wall. So yeah, I think that's a good bit of advice. Go for the thickest stud. Even if you went up to 120 mil, that would be better than 90. All right, so moving on now to a more alternative material, hempcrete. Hempcrete is an interesting one because hemp is a very ecological material. We're now allowed to grow it in Australia, and it it's just good for so many reasons in terms of how it's grown. It doesn't require a lot of pesticides or fertilizers. And when it's formed into hempcrete, basically a lime binder is used to glue all the little hemp particles together. It creates a very well insulated wall. They tend to be about 300 millimeters thick. So you do lose a little bit of floor space, and you can do some interesting things with actually not rendering the wall and leaving the hemp exposed and putting some colors in the mix as you're mixing up the hemp to leave an interesting aesthetic. One of my favorite materials is straw bale, and I would say that these walls probably have some of the best insulation around, but that's kind of because they're so thick. Straw bales just come in this very large format, so the walls end up being about half a meter thick, and the straw is excellent insulation, and of course it's a waste material from agriculture, so that really reduces its embodied energy and ecological impacts. And another interesting thing about it is it's very DIY. You can see here it's child's play. Um, uh, People of all ages can get involved. So if you're interested in that kind of do-it-yourself approach, something like straw bale could be good for you. Aircrete is another alternative but up and coming material. To be honest, I'm not a huge fan of it because I feel that it's still using a substantial amount of cement, which has high ecological impacts. But the idea is you minimize cement usage by foaming, by adding air bubbles. So what you see in the top right here is a foaming agent that gets mixed into the slurry of cement and sand and creates a sort of an aerated material. So it's lightweight, somewhat insulative, although I kind of question how insulative it actually is because, of course, the cement mixture is conductive. So that's causing pathways for heat to move from hot to cold. So in a similar vein, we've got autoclaved aerated concrete. It's better known in Australia as Hebel, and that's a similar sort of concept. The aircrete is a bit more DIY, but these blocks, of course, can be delivered to your site. And yeah, I'm just going to flag the poor insulative properties, and you do need to add some other layers of insulation to that. But yeah, might be, it's a very common building material, and not too bad because it is aerated, so it's not as much reliant on the cement. So I want to sort of do a bit of a dive now into earth building. I did already mention rammed earth, and on the right there you can see top right an example of an ancient city built out of rammed earth and mud bricks and other earthy materials. And part of the beauty of this is that when done right, these urban homes can be very energy efficient for heating and cooling. Of course, they've got low embodied energy at construction, and at end of life, they tend to just melt back into the ground without a trace. And there are examples that are thousands and thousands of years old. So here you can see a rammed earth wall under construction with some formwork. So formwork is set up and then the material is compacted inside the formwork. And you can get these beautiful layered effects with just slightly different colored material. One of the kind of potential downsides to this system is that, you know, there is a lot of material in there that has to be trucked to site. Typically, you'd be lucky if you can use the material that's actually on your site, which is sort of how it used to be done in the good old days. But now with higher standards for structural engineering, quite a bit of cement and steel ends up being buried in the wall to make sure it complies with code. But I still think this is a really terrific way of building. And my tip here is that you can embed a layer of insulation inside the wall. That's what they do in Canada, where it's very cold, and I would recommend that here as well, just to comply with the new 7-star energy minimum rating. And the other thing to do with these walls is just use them inside the building for thermal mass. So use, say, a straw bale wall for insulation as an external wall, and the rammed earth as thermal mass inside the building. And I would make that recommendation for the mud brick as well. Another ancient construction material, very ecological, but yeah, will require extra insulation to come up to code unless it's an internal wall. Now, this is my absolute favorite, and here you'll pick that I'm, I don't know, a bit of an extremist. I love these tire walls, and what I mean by bermed is that they get backfilled. So behind the tires, we mound earth up against the wall, so it becomes a retaining wall, and this becomes the ultimate protection from bushfires and also extreme temperature, because the soil is at a stable temperature, and of course the soil is non-flammable and can protect you from bushfires. And so in the bottom image there, you can see a tire wall. It's all been rendered over with another super sustainable material, which is an earth render, so that hides all the tires away. And I just love the concept of working with waste materials, which, the tires are a problematic waste material. You get them for free. You fill them with earth, which you can also get delivered to site for free. So I just really think this is a wonderful solution. Moving right along, super adobe and sandbags is actually sort of a similar concept to the tire wall, in that you're using some sort of container to contain the earth. In this case, some sort of polythene bag, and they tend to get used for dome-like structures. They work really well in that scenario, but you don't have to do domed structures. So moving on now to panels, cladding, and lining. So cladding refers to the exterior layer of your wall, and the lining is the interior lining to your wall. WeatherTex is a relatively new one that is quite sustainable and readily available. You can get it from Bunnings, and I'm sure other hardware stores. So yeah, it comes in all sorts of patterns. It's basically stamped into the material, which is compressed wood fiber, termite and mold resistant. Yeah, it's gone through that certification process and got a global green tag certificate. So yeah, I'd recommend that one. DuraPanel is a straw board. You can use it for walls or ceilings, and comes in a whole range of different finishes that sort of sandwich the straw. So I'd highly recommend that one. It's also got some good insulative properties because it's made of straw. Another straw material for the ceiling, and back in the 70s, I think a lot of beach houses had this straw ceiling in it. My parents had one of those beach houses, and that straw board is hanging in there. It's still going strong. It really hasn't degraded at all over about 40 or 50 years. So yeah, these natural materials can be very durable. Another example here, salvaged floorboards can be very durable. Oriented strand board or OSB can be left unfinished, as you see in the examples above, or it can be sort of painted. So the joints get a little bit difficult to deal with though, because you can't flush it like you would with plasterboard. So this illustrates that point quite well. You can see with the plywood, all the joins have been expressed. So there's a deliberate gap so that, yeah, you don't have to worry about getting everything to meet up perfectly. Probably about a sort of 5 to 10 millimeter gap there on purpose. Mini orb is also could be used for wall and ceilings. Custom orb is also another option. Custom orb or corrugated iron is the other generic term. And plasterboard, of course, is the go-to that most builders will do by default. And I don't know if you've been paying attention to the per square meter costs, but this one is the lowest. And it's no surprise that the material that is most common is the cheapest one. Unfortunately, though, not great for end of life. All tends to, or a lot of it ends up in the landfill. But yeah, look, also not terrible. So I think the trick is to insulate your wall well, and some gyprock is not to be sneezed at. Another interesting material is what are called structural insulated panels, which is what SIP stands for. So Bondor is one of the brand names, and this is basically a sandwich of polystyrene with metal cladding on both sides. And increasingly, you can get other materials other than metal cladding as a sandwich. So the advantage of these is that they're structural, so you don't need as many or much lighter roof beams. And like some of the walling systems with SIPs, that it's just the SIP. There are no studs or columns or anything like that. So that's a real interesting innovation up and coming. And so sarking membranes and wraps, reflective sarking, and the roof. This stuff is actually getting phased out because it causes problems with condensation, and a much better material for your project is going to be a vapor permeable wrap, which is sort of part of the system in passive house. That's the German passive house system. The great thing about these wall and roof wraps is it lets water vapor out. So the moisture from cooking and showering and all that kind of thing, doing laundry in the house, that creates high humidity inside the house, and that needs to escape. And what tends to happen is it then condenses on the underside of the roof, which is cold, and then it drips back down onto the insulation. So if you've got this layer of vapor permeable wrap, when it drips back down onto the wrap, it can't get through and it just runs out to the outside of the building. So on that note, let's talk about the roof. Roofs have minimum insulative requirements in the National Construction Code, which is what you see on the right. And that's all dependent on your climate zone. And an important thing to understand is that the color of the roof is going to impact the energy efficiency of your home and the star rating of your home. So lighter colors with this absorptance value are better. So you can find that it's the solar absorptance value SA is given for all these ColourBond colors. So keep that in mind when you're thinking about the color of your roof. Now, roof framing, I've talked about wall framing, and you're probably going to end up with your roof framing being in the same material as your wall framing. But there are options around things like what sort of timber framing will be specified, and that depends a little bit on the design of things. So these LVL rafters and I-beams may be the kind of thing needed if you have a pitched cathedral ceiling, but a conventional hip roof will probably just be made out of the what they call MGP, which stands for machine graded pine. So cladding materials, we've got the main options are sheet metal or corrugated iron, but there's sort of other profiles other than corrugated. You can have tiles, of course, which tend to be more heavy, or it could be, say, slate. And one of my favorites is earth-covered green roofs, which are very heavy and require extra structural engineering. So there's a slate roof and a green roof, or an earth roof. So earth roofs are really great for biodiversity. Of course, birds like them, and they're also really good for bushfire resilience, especially the extensive green roof where you're not growing massive plants on them. Just a small bushfire resistant ground cover. Or on my earthship roof, I just have gravel. So perhaps not great for the biodiversity, attracting birds, but absolutely fantastic for bushfire resilience. And so this is not my earthship, it's another one of my projects, but you can see the earth roof really blends in with the environment and it's not a bushfire hazard, and has got some really great energy efficiency outcomes as well. Windows and glazing. I'm not here to talk to you about design so much, but the one really important thing to understand is that facing the windows to the north is the really smart thing to do, unless you're in the tropics. But I know all you people listening tonight are not in the tropics, so face your windows north, and try to avoid putting them elsewhere. You might want to do that to get some views. If that's the case, try and make them smaller windows with good shade overhangs, good eaves. But yeah, for my talk on materials, let's look at the options for window frames. So basically, aluminium tends to be the budget one, but not so great when it gets really cold and you get condensation forming on the inside. So you can get hybrids of timber and aluminium where the aluminium is on the outside, protecting the timber from the weather, and this really improves the thermal performance of that window frame, so you don't have heat coming out in and out of the window frame. In this example here, you can actually see a triple glazed window, 3 layers of glass, and so there's kind of no point having that triple glazing or double glazing if there's a lot of energy moving through that frame. So this is going to cost a little bit more though. You can also get plastic window frames. It's UPVC is the material. Just think of it as PVC, and that the main idea of that is to stop that issue with the heat loss. They're also quite economical. There's always a downside. There's always an upside and a downside. So the downside is that perhaps not so great in a bushfire, because yeah, the plastic is going to melt at a lower temperature. But often they have, what you'll notice in that one is there are steel sections in there which give it a little bit more structural integrity during a fire. Timber, of course, is the classic ancient material used to build window frames. And in this example here, it's a painted one, but you can use hardwoods that don't need painting, but will need oiling. So it's really the ongoing maintenance with timber that can be the deal breaker with timber. But of course, it's really beautiful, and it's a renewable material. But we can't discount the impacts of forestry. So try and source that FSC certified timber. And another idea on the window frames is this product called magnetite. Basically, it's a retrofit solution where you can just magnet on like another layer of glass. So this is how you can retrofit double glazing rather than ripping out all of your existing windows. You can just magnet this on, and even if you've got timber window frames, there's a frame installed that this one can magnet onto. So yeah, I think that's a really interesting idea. All right, so now thinking about the window as a whole, not just the frame, but the glass as well. There is this system called WERS, which you can log into and figure out what the insulative value of your window system, frame and glass is. Now, yeah, hopefully you're going to have a double glazed unit or an insulated glazed unit. So IGU and DGU are kind of mean the same thing. Triple glazing is not very common in Australia. So if possible, if you're getting new windows, go for double glazing. And these are some of the key measures for how you're going to know if you've got good windows. So we've got the U value, which I explained earlier, the opposite or the inverse of R value. So a lower U value is better. We've got the solar heat gain coefficient, which is how much energy is going to come through that glass. And also how much light, how much visible light is actually going to come through. So the type of glass is going to influence all these things. I've just explained that. And also good to know that there's all sorts of different types of glass. It can just be clear glass, or it can be tinted with some kind of nano film. So this is often called low E or low emissivity glass. You can have it tinted in other colors. It can be laminated for strength. That's maybe how it gets its color, but also for energy efficiency. And it can be toughened for bushfire or low windows that you might crash into and hurt yourself if it's going to break into really sharp pieces. So here's a screenshot of the WERS search engine where it actually lists a whole range, hundreds if not thousands of windows that you can buy from window manufacturers, and then you can then look at that U value, the solar heat gain coefficient value, and start comparing. And like it's even giving star, a star rating for cooling and heating. And then, yeah, here I've just sort of highlighted the U value and the solar heat gain coefficient shown on a NatHERS certificate for a home or extension, and this is calling out the values, the minimum values that are required to achieve that 7.6 star rating. And so there's some references here. You'll all get a copy of this presentation, so you can refer back to this. The bushfire standard also has some important information about the timber that can be used for window and door frames. So if you are in a bushfire zone, then you'll need to pay attention to this standard. Unfortunately, the standards are all hidden by a paywall. So the Australian Glass and Window Association do have a really good guide to that standard, so you don't have to buy the standard. And so I'd just like to spend the last 5 or so minutes just looking at a case study. Um, so it's inspired by the Earthship concept, which I like to think of as passive solar design on steroids. This is where there's really just no compromises, and basically all the windows are on the north side where they should be. This is a 2 bedroom, 1 bathroom building on a small suburban block of land that cost about 400,000, including all the off-grid systems. All the windows face north, and what's more, there's a greenhouse or sunroom on that north side, which is kind of like the solar heater. And interestingly, it works as part of the cooling system as well by drawing fresh air through underground pipes called earth tubes. Um, and then there's also the earth mound at the back, which also buffers from extreme temperatures. So here is a rendering of the building. Um, Here are the shade diagrams that show essentially no sun coming into the building in the summer. In the winter, the sun can penetrate deep into the living spaces, and at the equinoxes, only really the sunroom gets sun. Maybe a little bit's creeping in the afternoon. And there's the floor plan showing that greenhouse or sunroom on the north side. It has straw bale walls for really great insulation on each end. It has the tire wall, which, if you don't like tires for some reason, could be rammed earth, or concrete block is another option, but nowhere near as ecological. Um, then there's the earth berm or the earth mound behind, which is actually where we're putting the wastewater. So that means we don't have to irrigate this. This is essentially a garden. And then the earth tubes, which are bringing in the fresh air. So here in cross section, you can see basically as it gets warm in the greenhouse and the hot air escapes out of an open window, that draws fresh air in through the tube into the living room. And I've recorded 22-degree air coming in here on a 42-degree day. So you can get about 20 degrees of cooling with this earth tube system. The other concept with the Earthship is that the greenhouse and the earth berm act as buffer zones. And what this means is that the living space is buffered from external temperatures. The temperature of the soil is about a stable 20 degrees, and then greenhouse, it's always a milder temperature than what's going on outside. So this is leading to buildings that basically do not need heating and cooling at all. The other interesting thing about these earthships is that they're built by volunteer labor. So volunteers sign up to come and help build the tire wall. It's a really easy to learn system. And that also applies to the earth rendering technique. You can see the earth render going over the tire wall, and on the right, a straw bale wall with earth render on it. But also we also used plasterboard for ceiling and wall. So these construction methods can be all combined, and just using the appropriate materials in the appropriate places leads to a really good outcome. And so there's the finished rendered tire wall. The fire has not been needed due to that sunroom and earth berm. There is the straw bale wall. One of the really cool things about straw bale walls is you can carve niches into them because they're so thick. We also upcycle bottles in earthships, entirely optional, but sort of a very cheap brick, and it's sort of building air into your wall, which is insulative. There's Amy, the happy owner, and there are a couple of YouTube clicks there that you can click on. They're both links to learn more about that building. Also in Victoria, closer to all of you, there's an earthship in Mollinghip near Ballarat under construction. There's the 2-bedroom floor plan. You can see all those earth tubes or cooling tubes out the back, the greenhouse or sunroom on the front. There it is under construction as of January 2024. It's been owner built. And so moving on now to renovation ideas, the real quick and easy things to do is for draft sealing. For probably under $100 at the hardware store, you can get sticky back adhesive strips to put on your windows, weather seals for your doors, and this is going to stop the drafts. And this is a big deal. Australians live in really, really drafty homes. And so, yeah, dealing with this problem is a great first step. And if you are doing a new build, then make sure that your windows and doors have these seals built into them. Ceiling insulation, of course, I think everyone knows about this by now. That's a really important thing to do. And my tip would be to actually exceed what the code says. The code might say to go for R5 in the roof. I'd try to go for R6, 7, or 8 if your budget permits and if there's space. Double glazing, I gave you the example of the magnetite retrofit, or if you're not happy with the magnetite, then install double glazing. That they're all sort of relatively quick and cost-effective upgrades. Then, some ideas if you're doing an extension to your home, so something a little bit more significant and costly. I would like everyone to consider the idea of that greenhouse or sunroom or atrium that is sort of the heart of the Earthship, the thing that really makes it tick. I feel like that would be a really wonderful way to improve the thermal efficiency of your home. It also gives you a beautiful space to be in. It's not always comfortable, in the middle of summer, but, come the summer evening, you open up the windows, it cools off. And of course, in the winter, it's absolutely glorious on a sunny winter's day. I think there's just many examples of people adding a sunroom and really enjoying that idea. And my other idea related to that is if you can add a laundry or a bathroom as part of that sunroom, then you have a source of grey water. That's another key concept of the Earthship is that is upcycling water. And so what you see here is the sunroom on an Earthship in New South Wales that actually has the washing machine located in a little cupboard here, hidden out of view. And then the grey water from that can very easily be diverted into the garden bed. I just feel like that's really sensible to combine those two ideas. If you needed a second bathroom, third bathroom, whatever, you could incorporate that also at the end of the sunroom. So here is a list of resources and references. I'll give it one more plug, the Your Home website. It's got links to passive design and materials. That's your homework to go check that out. And so in conclusion, there's no perfect solution for all sites and all people. It's context specific to your climate and your budget and all sorts of other things. So really need to work closely with your designer or architect to tell them what sort of materials you like. What's your philosophy on environmentalism? Are you an absolute tree hugger like me and want to go all the way, or do you want to just do a little bit here and there? Like, that's of course your call, and you need to let your designer know about that. And from there, you'll co-create that design and figure out what these materials are. And of course, you can dramatically reduce the cost of your home by building small and efficient. And you can also dramatically reduce your eco footprint by thinking about these life cycle stages. So I think that is everything. Thank you, everybody. Have you got any questions?
Thanks, Martin. We do have a couple of questions. That was incredibly practical, a lot to take in. So just letting folks know that you'll get a copy of all that afterwards. We'll go to Helen's question, and you may have answered this, but what are your thoughts about metal cladding, which you see used for many extensions now?
Yeah, well, the great thing about metal cladding is that it is so durable. And one thing to keep in mind is if you're by the coast, the salty air can affect metal cladding. So you want to get the metal cladding that's designed for if you're by the coast. So I think it's fine. It's a highly recyclable material. Make some sensible choices about the color. The thing I don't love that I see these days is people love the really dark colors, which is just sort of causing issues with heat. So if you can go for the lighter colors, that would be my top tip there.
Great, thank you. Catherine says, I really like blown-in cellulose insulation for ceilings, which is widely used in Canada and Europe. I wonder why there are not more cellulose blown-in ceiling insulation offered in Melbourne. Do you have any reflections on that?
That is a great question. I think it might be to do with the fact that we don't really have phone books anymore, because phone books used to be the things that got pulped into cellulose insulation. But I guess there's still lots of other waste paper streams. So I don't really know why. I think it's a good material. I should actually add it to my presentation. But yeah, I guess if there's not a lot of suppliers in Melbourne, that's interesting. I don't know why. It is a good material. I recommend it. Yep.
Okay, great to know. Folks, we've got, obviously Martin is just incredibly knowledgeable. So if you've got any last minute questions, do go to the Q&A and put them in. I will, I've got some because there was so much interesting stuff in there. I was really interested by the burn tire wall, particularly for its bushfire resilience. Obviously going into a more volatile climate. Ideas like this, do you find becoming more mainstream?
Uh, no, I'd say not. Still, it's a very niche fringe idea. I think the idea of building a wall out of dirty, grotty old tires, it's just an appalling idea to most people. But I actually, I think the exact opposite. I think it's just a wasted resource. And like, I think every state in Australia has a massive stockpile of just like millions of tires. Like we make about 60 million every year, and so I just see it as an untapped resource. And the other thing I love about it is that people can get involved in the construction of their own home, and I kind of understand that not everyone, in fact, only a very small number of people want to actually get involved. That most people just want a builder to go deal with it. But I just love the idea that we humans can create our own shelter.
Yeah. Eva asks, is there any way to retrofit insulation to a wooden floor?
Okay, so Eva, if you're talking about, I mean, obviously putting it above the floor is not going to work. It would have to go below the floor. So depending on I'm assuming you've got a timber framed floor with timber floor joists. Yeah, maybe there's some options for like blow in materials. It could be like a sprayed in spray foam, or the blown in cellulose that we were just talking about. If you don't have I need to know more. Like, if do you have access underneath the floor? I'm assuming not. Um, if you did have access underneath, then you could potentially get in underneath and install rigid polystyrene, or there'd be a whole lot of other options. But
Cool. Yeah, I think in this webinar format, unfortunately, Evie, you can't unmute yourself and give more details. Feel free to pop them in the chat. Doug from Renew has just put a link in what is underfloor insulation. I don't know if that's helpful, but feel free to put a few more details in the chat. In the meantime, I'll move to Jennifer. What is the best, most sustainable, healthy DIY option for wooden floor treatments? E.g. water-based, wax or oil. I also wonder the same for timber window frames.
mm, Yeah, I think there are some great suppliers out there formulating these kinds of products for furniture, floors, out of things like beeswax, uh, various oils from like nuts and trees and all sorts of natural sources. I gave the example of linseed oil. So yeah, there's one called bioproducts. So you might like to Google bioproducts, paint, um, floor oil, sealer. I think, yeah, it's those ones that are typically water based, or the ones I'm thinking of actually, they make their own thinner, which is like terps, but they make it out of orange peel. And so it's like those volatile oils in orange peel that they, concentrate. And I mean, you still don't want to drink it or anything, but yeah, it's coming from natural sources. And yeah, issues like off gassing are not going to be they're not going to be issues. So yeah, maybe I can also find a, or maybe Doug, could you do a search for bioproducts or bio paint? There's a
And
manufacturer near me in Mount Barker, so that might help with the Google search as well.
yeah, that probably relates also to Anna's question. I'm concerned with chemicals used in buildings, in paint, sealants, etc. Would you be able to point to a resource with alternatives? So possibly that bioproducts is the right place to look.
Yeah, and I think the rule of thumb with paints should be if it's a water-based paint, it's far less likely to create what they call VOCs or volatile organic compounds. So also just walk into your paint store and just say, look, I want a low VOC paint. And they should, if they can't help you, then go to another store.
That's right. Don't take I don't know what you're talking about for an answer.
Mm.
Thank you. Catherine asks, any advice on split system versus multi-head for heating and cooling? So I'll put it up so hopefully you can see. But she says split system, one heat pump outside and one unit inside versus multi-head, one heat pump outside and multiple vents inside in a proper insulated house.
Yeah, I'm not really an expert on that, but what I do know is that with the split system, it enables you to put your tank inside the house. The compressor needs to go outside, and then having the tank inside may be beneficial, especially in the winter, to sort of have that heat from the tank warming up the inside of the house. But yeah, look, it kind of wasn't on my radar for tonight. It's sort of a bit off topic to the
Yeah.
materials. So that's kind of like your heating and cooling kit. Sorry,
Yeah.
I wasn't
No, that's
wasn't
all
really
right.
ready for that one.
Well, no worries. Well, there are just so many resources out there. So do, again, everyone feel we're going to send it all to you. We're going to send you the links. If you can't take it in right now, we are at 8:30 and I want to be respectful of everyone's time, including Martin's. So, I am going to, close off the Q&A there. So I really appreciate everyone. Thank you for attending today. We will, when you close this session, a feedback survey will come up. We'd really appreciate you completing it because it helps us to improve our webinars. Let us know what you think. We do have another webinar in this series next Tuesday on making sure that your house and garden are water-wise, climate resilient. So come along to that for some good info as well. And we also wanted to shout out that this Sunday is Sustainable House Day. So around Melbourne, there will be many, many sustainable homes that are celebrated for their, climate and sustainability chops. So get out and go and see some in your local area. We know there's at least one in Stonington, at least one in Glen Ira, and also some in the local surrounds. So it's a really good place to get inspiration and you can talk to the homeowners there. But yeah, thank you so much, Martin. It's been so informative and hopefully really valuable for our attendees.
Thanks, Remy. Thanks, everybody.
Thanks, folks.